So the first question is, LCM of smallest two-digit composite. Yes, everyone, please turn on your camera. Yes, Harshit, Ibad, Fazan, Galvin, Gungun. Yes, please turn on your camera. LCM of smallest two-digit composite number and smallest composite number is to it.
20.
20. Maha has got 20. Rest of the student 40. Okay, Zanab got 40. Maha has got 20. Yes, rest of the student, what you have got? Is it 20, 40 or any other number? Quickly, please let me know. This is MCQ question, so of course, options I have not given. Just it's completely okay. In exam, definitely you will be getting options, but you must give less time. What will be the answer?
40.
Okay, let's check. Is it 20, 40 or what? So LCM of smallest, I mean 20. Okay, let's check. Whatever. Okay, 20, 40. What will be the answer? Let's check. Smallest two-digit composite number. Now, two-digit number starts from after 9, 10 is
10.
there. So from 10, okay, then 11, 12, 13, 14. These are the two-digit numbers, and the smallest one is 10. Right? Is it composite number? This 10 is composite number.
Yes.
It
Yes.
is composite number. Okay. 10 is, of course, it's a composite number. Okay. Smallest two-digit composite number is 10. And smallest composite number is
4.
4.
4. Okay. The smallest composite number is 4. So yeah, let's check it. What will be the LCM of 10 and 4? 10 means 2 into 5. 4 means 2 into 2. while finding the LCM, what we do, first we write the common factor. Here 2 is the common factor, so 2. Now forget about it. Remaining term will be taking, because after that there is no other common factor. So 5 into 2, and LCM is 5 2 times 10, 2 times 20. 20 is the correct answer. Okay, yes. So yeah, let's proceed. Write the number of zeros in the end of a number whose prime factorization is 2 square, 5 cubed, 3 square, 17. Sum up 2 zeros के बाद 2 zeros. Okay, so yeah, let's check it. This question, if you will start doing all the multiplication, it will take time. Please don't do so. Okay, you don't have to multiply everything. If you understand the concept, then you must understand that for getting zeros we must have the combination of 2 and 5. Okay, that will give 1 0. Okay, 2 and 5. So here 2 times 2 is there, here 3 times 5 is there, and we, whenever we'll be having a pair of like a 2 and 5 together, we'll be getting 1 0, we understand. So a 2 and a 5, 2 5 came together will give 10, 1 0, and another 2 and 5 will come together, will give 1 0. That means only 2 zeros will be there. Getting it?
Yes.
Okay, 2 zeros will be there. Let's proceed. The LCM of two numbers is 2400. Which of the following? I'm going to give the option over here. cannot be their HCF. A 300, B 400, C 500, and D 600.
Five hundred.
Wait, we check. Yes, rest of the student. Ibad also says 500. Okay, we will check it. Yes, Aisha.
Ma'am,
Yes.
500.
Okay, Galvin also says 500. Yes, Aisha.
Yes, it's 500.
Okay.
500.
Okay, anyone, can you tell me how you got this 500?
Since in the 300 table, when we multiply it by, like in the 300 table, 3 table, we will get 24. And then in the 4 table, like 4 6 we'll get 24. Then 2 zeros, so 200, 2400. In the 500 table, we won't get 2400, right? Then in the 6 table, we can get 6 into 4, 24. Then 2 zeros, 2400. But in the 5 table is the only one where you cannot get 24, so it's 500.
Oh, yeah. Yes, that is the concept. Okay, basically the concept is 500 cannot divide 2400, or in the table of 5 or 500. From 500 we won't be able to make 2400. That's what she's trying to say. Yes, perfect. Okay, that is the concept. I'm trying to explain it over here, a little bit of explanation. Whenever we are finding the HCF, let's say we are finding the HCF of two two numbers, that is 12 and 24. Okay, so while finding the HCF, we take the common factor, right? Common factor. Let's find it. 12, it will be 2 2 3, and 24, it will be 2 2. Is it 1 more 2? Yeah, this is what we have got. So HCF will be 2 with 1 more 2 and 3. This is the HCF, right? And what will be the LCM? So common factors, this is common, this this is common, and 1 3 is common. Okay, so while writing the LCM, we write the common factor also and extra, all the extra factors also. So 2 is extra, that is the LCM. Now if you understand the concept of HCF and LCM, you can see here that HCF, this HCF will always divide this LCM completely, because while finding the HCF we have taken only common factor, and while finding the LCM we have taken the same 2 2 3 we have taken initially, the common factor, and then extra factors we have taken. So of course, logically HCF will completely divide LCM always. Okay, here also which cannot be the HCF, that means whatever this, if 300, suppose 300, can it be HCF? If it can completely divide our LCM, then maybe it can be. Okay, if 400, this can be completely, if this number, if it can completely divide our LCM, that is 2400, then maybe it can be the HCF. Am I making sense to all of you?
Yes.
Yes.
Okay, So yeah, the same concept we are using. We are checking by dividing 2400 by 300. It is completely dividing. 400 is completely dividing. It can be the HCF. And here we have to mark the option which cannot be the HCF. So 500, if you will try dividing 2400, it will not divide it completely. So definitely this cannot be the HCF, and remaining can. Okay, depends upon the number given. Let's if A and B are two co-prime numbers, then A cube and B cube are options I have to give over co-prime, not co-prime. Please check it which one is the correct option.
A co-prime.
Okay. Yes. A co-prime. Aisha also says co-prime. Okay, yeah, let's check it. Will it be co-prime or not? So when A and B are co-prime number, what does it mean co-prime number? Co-prime numbers are those numbers which doesn't have any common factor other than 1, right? Right?
Yes.
Yes.
Okay. Co-prime numbers are such a numbers which doesn't have any common factor. Okay. It can be like both the co-prime numbers can be even number, can be odd number, whatever. Okay, one can be even, another can be odd, but the condition is both doesn't must not have any common factor. So if A and B are co-prime number, A and B are co-prime number, then A cube, A cube means A times A, and B cube means B with one more B, and there is one more B, one more B. Now since A and B doesn't have any common factor, so even if we will multiply A with one more A with one more A, and B with again one more B and one more B, again it both will be co-prime only. Even and odd we cannot say. We don't know both are even, odd, or what. Okay, so either we can say not co-prime or we can say co-prime. But here if you will see the pattern, it is just co-prime. Again there will not be any common factor. Getting it? Getting it? Yes.
Yes.
Yes. Let's continue. Right. the smallest number which is divisible by 306 and 657.
Teacher, is that 654 or 657?
It is 657. Azan has already messaged that it is 3. Yes,
Ma'am, it is 3.
okay. Yes, rest of the student are waiting for your response. Ibad has messaged.
I'm 3.
Exam also says 3.
Ma'am,
3.
3. Ma'am.
Okay, 3. Okay, let's check it. Here the question says write the smallest number. Okay, smallest means minimum, the least number, which is divisible. Now divisible means I'm just replacing this divisible with completely divisible. Okay, that's what the meaning of this terminology. Divisible means completely divisible. Okay, so we have to write the smallest number which is completely divisible by 306 and by 657 also. We have to write a smallest number, that is 3, which is completely divisible by 306 also, and the 3 is completely divisible by 657 also. Is it making sense? Are you getting it? The answers which you have said to me, I am writing it. 306 is completely dividing 3, and this, the other number 657 is also completely dividing your answer. Okay, because we are supposed to write the smallest number which is completely divisible by this also and by this also. So are we going to find HCF or LCF? The smallest number which can completely
HCF.
divide. Let me write the other scenario also. Write the smallest number which can completely divide 306 and 657. Is there any difference between these two questions? I'm rubbing this part because it is completely invalid, whatever I have written. Okay. Okay, let's read it. These are two different questions. Okay, now tell me in with let me mark it with number so that you will be able to answer properly. This is suppose question number 1 and this is question number 2. Now if for question number 1, LCM or HCF?
HCF.
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 Okay. And for question number 2, LCM or HCF?
HCF.
This is also HCF. Yes, rest of the student. Are you thinking the same?
Yes.
Okay, let me explain. See, the first one will be HCF and the second one will be LCM. Now let me explain it why it will be LCM. Because we are finding the smallest number which itself is completely divisible by this also, by that also. For the second number, I'm just keep it aside the first number. Okay, second number. We are finding the smallest number which is the number which you are finding that is okay divisible by 306 and the same number is divisible by 657. That's what 3. Now 3 is completely divisible by 306. Is it so? Yes or no?
Yes.
3 is divisible by 306. Zanab, 3 is divisible by 306.
No.
Okay, 3 is divisible by 657. Is it making sense? No, fraction will be getting over here. 3 is not, 3 can divide 657, but 3 itself is not divisible by 657 and 306. So the same type of question, there are two different scenario which can come in exam and you have to read the question very carefully. Okay, here the question says that write the smallest number which is divisible. Okay, forget about completely divisible, which is divisible by 306 by 657. While finding the least common multiple, what we do? Least common multiple. Suppose we are finding the LCM of 4 and 10. So what we do? Basic, the concept is we have to list down the multiple. Okay, this is what you don't have to do like this, but I'm trying to explain the concept over here. We list down the multiple of 4. 4 1 times 4, 2 times 8, 4 3 times 12. Okay, 4 4 times 16, 4 5 times 20. Okay, and after that also you can keep on writing the table of 4, that means the multiple of 4. Now the multiple of 10, 1 times 10. Okay, 10 2 times 20, 3 times 30, 4 times 40, 5 times 50. You can keep on writing. Now for finding the least common multiple, what we do? The common multiple, the very first, very least common multiple. So we check this 20 is here and 20 is there. That is the first common or the least common multiple. Hence, the LCM of 4 and 10 is 20. Now this 20, okay. Now this 20 is the smallest number. See that the 20 is the smallest number which is completely divisible by 4 also and by 10 also. Yes or no?
Yes.
Yes or no? 20 is the
Yes.
smallest number. Let me write 20 is the smallest number which is divisible by both 4 and 20, 4 and 10. This statement is correct, right? Right?
Yeah.
Okay. So we have to find the LCM for the second scenario, the second question. Now, why we are going to find the HCF for the first question. Let's read it very, very, very carefully. Okay, it says that write the smallest number which can completely divide. The number can divide completely 306 and 657 as well. Number is dividing 306 and 657 also. And here the number itself is divisible. Are you getting the difference between both the questions?
Ma'am,
Yes, Maha.
ma'am, in the second question, does it have to like completely be the number? Does it have to be completely divisible by both 306 and 657?
Yes, it has to be whenever in mathematics, Maha, in any of the question, whenever this divisible word is there, that this is divisible by that, that means the remainder is zero. It is completely divisible. Okay, are you getting it? Divisible means completely divisible. Okay, 8 is divisible by 2, that means of course completely divisible. Okay, we will not say that 5 is divisible by 2. We will not say that. Getting it?
Yes.
Maha, are you getting?
Yes, ma'am.
Okay, so these are the two different scenarios. When this type of question will be there in your exam, read the question very carefully, that the number which you are going to find, the smallest number, the number itself is divisible by the given number, or the number is dividing the given number. If the number is dividing, then of course the answer will be 3. Okay, for the first question, answer will be 3. But for the second question, now find the answer. Find it. It will not be HCF. Find it. See, Bad, I can recall that you have message in chat box when I was reading. Okay, Fazan has already given the answer. Is it this 22338? Please check it. Yes, Ibad, when I have given this particular question, you have written a big number, a huge number, which I'm not sure it was 22338 or what, but it was big number, and it looked like that it is LCM. Yes, let me know what is the answer.
So teacher, the question we are doing is completely divisible or only divisible?
Only divisible and completely divisible is the same thing, Fazan. Okay.
Then why did you write question 1 and 2?
Ma'am, I got the answer.
Question 1, if you will read, yes, Maha, I am coming to that. Question 1, if you will read carefully, there it is written that completely divide. Divisible means completely divisible. Itself, the number is divisible. And completely divide means the number is dividing 306. That's what I was explaining over here. Okay, that the number is dividing. Completely word is not the keyword. Okay, completely word is not. Even if completely is there, not there, just divisible, just divide is there, that means we have to understand divisible means completely divisible, divide means completely divide. Okay, question number 1, Fazan, it is written over here that write the smallest number which can completely divide. Such a number we have to find which can divide 306 also and which can divide 657 also. And I was explaining that for that particular case we'll be
Ma'am,
finding the HCF, and that is 3. Yeah.
Okay, teacher, I got this.
ma'am,
Yes. Yes.
ma'am, the answer is 22 and 338.
Yeah, so everyone is getting the same, it must be the answer. Yes,
I also got
this
the
is the
same
answer.
answer.
Yes, everyone. Okay, so yes, this is the answer. Okay, let's proceed. Now the next question is 3 bells ring at an interval of 4, 7, and 14 minutes. All 3 bells rang at 6 a.m. when the bells rang. Yes, please do it.
Ma'am,
Yes,
ma'am, the
Arshit,
answer is 628. Like,
628. Okay, 628. The time
620.
you are saying
Yes,
after
the
6
time.
a.m. Okay,
Yes,
got
ma'am.
it. Yes. Okay, yes, rest of the student, what are you getting?
Also getting 6:28 minutes.
Okay, so yeah, let's discuss it. Everyone getting the same? Yeah, I can see. Yes. Okay, let's solve it and let's continue. So 3 bells are there ringing at an interval of 4, 7 and 14 meter. Most of the students have already done, still I'm explaining since I'm explaining all the questions. Little bit of explanation over here. So all 3 bell rang at 6 a.m. At 6 a.m. all 3 bell rang. So the first bell is ringing at an interval of 4 minutes, next one 7 minutes, next one 14 minutes. So it will look like this. The first one will ring after 6, after 6 it will ring at 6 4, then it will ring at 6 8, then it will ring at 6 12, then it will ring at 6 16, like this. Okay, the first bell, because it is ringing at an interval of 4 minutes. Okay, now the next bell is ringing at an interval of 7 minutes. So at 6 7, then 6 14, then 6 21, then 6
Teacher,
28.
we can
This
just
is how
find out the LCM and then
exactly we can directly find out the LCM, and that's what I am trying to explain over here, that 4 8 12 16 7 14 21 28, we are just writing the multiples over. So that's why we find the LCM always whenever this type of question is there, that one person is just making a complete covering a circle in this by taking this much time, another person is taking this much time. Why we always find the LCM? Because when we write the pattern, eventually we find that we ended up writing the multiples, and since we have written the multiples, of course we have to focus on finding the least common multiple. Okay, so here also the next bell is ringing at an interval of 14 minutes. If you will be writing, so you will see that we have to find the what will be the time next time all the bell will ring together, what will be the time all the bell will ring again, okay, together for the very first time. That means least common multiple, which we were discussing over here, and hence we are finding the LCM for this type of questions. Okay, so this much is just the concept. Let's continue. Please do it now. Options are there. Yes, please do it quick, quick, quick.
Ma'am,
Yes, Harshit.
it is 6:25.
It's 25 option. Okay, yes, everyone getting the same. Yes, everyone getting 625.
yes.
Okay.
Yes.
Yes, Harshit, what you have done?
Ma'am, basically it is saying that we have to find the greatest number which divides this. So first we'll minus 125 from my 1, then 9377, then 2. Then at the end we'll find the HCF because it is saying that no greatest number. So that
Yeah, HCF we have to find here, and whatever is the remainder at first only we are just subtracting it and keeping it aside. Okay, and then we are focusing on finding the HCF. Yes, everyone has done the same thing.
Ma'am, can you explain this once again?
Yes, sure. Here the concept is we have to find the greatest number which when divide this and this leaves the remainder 1, 2, 3. Now if you can recall, there was formula that dividend is equals to divisor into quotient plus remainder, right? Have you seen this formula?
Yes, ma'am.
Okay, so we are supposed to find the greatest number which when divides 1251, 9377, and this one. So these numbers are getting divided. These numbers are getting divided, okay, by the same number, and the last one by the same number. Okay, by the same number, but we are getting the remainder as a 1, 2 and 3 respectively. So basically, if the dividend, this is called dividend. Okay, if you have forgotten this concept, let me clear it. This is dividend, and the number by which you are dividing, that is called divisor. Okay, and quotient and remainder, I know nobody forgets. So dividend is 1251, divisor, whatever whatever will be the divisor, we are supposed to find a divisor, into quotient is q, and remainder we want to maintain the remainder as a 1 for the first number. If you will try simplifying it, can you see this one we can pull to this side and we can do the subtraction from this 1251, and we'll be left with this divisor with quotient. Can you see it, Gungun?
Yes, ma'am.
Okay, so that's why we are doing the subtraction. Whatever remainder has to be there, at first only we are doing the subtraction, and we are saying that now 1250 is the number, and we will be thinking about such a number which can completely divide it. Okay, remainder and all, we don't know how to process with that, so let's keep it aside, the remainder. At first let's make it 1250. Now we'll be thinking about a number, what is that number which can completely divide 1250. Okay, no remainder and all. Okay, or maybe the remainder is 0. Similarly, we
Okay,
are
ma'am.
thinking about all the numbers 9377 and the last number. We are first we are keeping just subtracting the remainder, and then we are thinking about finding such a number which can completely divide. Okay, 9 after subtracting it, subtracting 2 from it, whatever we'll be getting, which can completely divide it. Okay, now if I will tell you this question again, find a number which can completely divide 1250, the next number and the next number. Of course, HCF we have to find, right, Gungun?
Yes, ma'am.
That's why we are finding the HCF. So this is the concept, and the short trick is whenever you find greatest, this terminology, that means it is indicating the highest common factors, highest common factors. This greatest and highest, these two are synonymous word. So whenever, most of the time